Good day to all. Today I'll discuss about the research facilities and outcomes of the work package 1.5 titled Fault Tolerant Operation. This is the real-time digital simulation test facility available at IIT Kharagpur. This facility is based on NovaCore simulator from RTDS Technologies. There are 2 racks with 3 NovaCore chassis and 2 cores licensed on each chassis. Additionally, there are low and high voltage digital interface panels, digital input-output cards, analog input-output card, inter-rack connection ports, GT sync cards, global bus hub, etc. Further, there are a few communication protocols installed on these simulators for interfacing with the physical devices like PMUs and other protection devices. Due to its innate capabilities, large-scale real-time simulations involving wide area protection and control testing, distributed generation, smart grid, protective relay testing with IEC 61850, etc., can be performed with this test facility. Broadly, in this work package, we have targeted control strategies focusing on voltage fault rate through operation, islanding detection, island formation, and power sharing in island microgrid. We have considered a microgrid based on renewable DG unit, energy storage unit, local loads, which are all connected to the utility grid through a DC to AC bidirectional converter. The proposed control strategies are validated through real-time digital simulations involving NovaCore RTDS simulator through RSCAD programming interface. This is the home screen of the RSCAD programming software. And this is the draft file where the entire microgrid along with the proposed control strategies is modeled using the inherent components available with the RSCAD library. The system is modeled into 2 subsystems, whereas the subsystem 1 contains the physical components of the microgrid like sources, storage devices, loads, utility grid, power electronic converters, along with the switching pulses generation for these power electronic converters. The second subsystem comprises of the blocks that model the proposed control objectives in this work. Upon completing the modeling of the entire system, this draft file is compiled to generate the runtime file that is used to run the model in real time on the NovaCore RTDS simulator. This is the runtime interface of the draft file that was compiled previously. Various test conditions like faults, islanding, load change, etc. can be applied here, and the response can be studied in real time. For example, here I am applying few test conditions for a duration of 5 seconds. These test conditions will be applied to the model and the plots will be updated in real time as per the response of the test conditions, as we can see here. These plots can then be further saved for further processing and analysis. To summarize, we have proposed a control strategy for VFRT operation of a microgrid based on an adaptive dynamic voltage support scheme and an islanding detection algorithm based on the second harmonic impedance drift technique. In continuation, we have proposed a coordination technique between the VFRT operation and islanding detection, considering their coexistence and antithetical requirements. Then we have proposed an algorithm based on the second harmonic impedance estimation for accurate power sharing in an island microgrid. Further, a modified affine arithmetic-based continuation power flow analysis technique is proposed to determine the PV curve bounds under uncertainty with the renewable generation. Finally, we have validated all the proposed controls using real-time digital simulation. The final outcome of this work package is a software tool with the proposed control objectives with a TRL4 level validation. Thank you.